Hello, welcome to Physics Basket. Today we are going to discuss on topic 14, Class 9 Foundation, and the topic is again we are going to continue the problems on motion. So let's get started. So let's get started with the first problem. It says that a metal of mass m, which is equal to 50 gram, that is kept horizontally in air by firing bullets of mass 10 gram each. So bullets are being fired in the upward direction and at the rate of 10 per second. That means 10 bullets are fired per second to keep this particular metal plate in the horizontal shape, right? It's to keep it from falling down. If the bullet rebound with the same speed, so it is being fired and it rebound with the same speed. So what is the velocity with which it is fired? So basically we need to know that with what velocity this 10 gram bullet at the rate of 10 per second is being fired towards the plate which is of 50 grams, that it gets balanced, and we should know what is the velocity. That is the ask. So this is a plate, we can say, and say capital M is the mass, which is nothing but 50 gram. We already know G is, so total weight will be mg acting downwards, and we will have bullets being fired towards it. So given mass is already known, 50 gram, we can convert if required to 50 into 10 to the power minus 3 kg. Similarly, we have uh, the mass of the bullet is 10, and per second we have 10 bullets being fired. So number of bullets is 10. So number of bullets is 10. Okay. Now this is the situation. The bullet goes with a velocity u and then it rebounds back with minus u. All right. Because the direction changes, so we'll keep it as minus u. All right. Because the velocity is dependent on direction. Now with this, if we are able to find the momentum, then we can also find the rate of change of momentum. So the every second we have 10 bullets being fired. So the time of impact for each of the bullet is what? 0.1 second, right? So we have 10 bullets. So every 1 second we have 10. So so time of impact is 0.1 second for each of this bullet. Now we know the mass of the bullet also, which is 10 gram, 10 gram. So with that, let us assume that the uh, speed at which the bullet is fired is u, and the speed at which it rebounds back is minus u, right? So with that, we will be able to find the momentum change. So, and the change in momentum is what is going to help this particular mass to stay intact in air and balance its weights. That is what is basically balancing its weight downward, and it's staying intact. So that is how we are firing. So with that, our already we know that velocity of rebound and velocity of at which it is fired is u and minus u respectively. So what is the change in momentum? It goes with mu and comes back with minus mu. So we'll say mu minus minus mu, right? So change in momentum is initial minus final momentum. So for us it is 2 mu. Okay. So the total change in momentum is 2 mu, and the weight acting downward is being balanced by this change in momentum. But we know force is basically what? Rate of change of momentum, right? So m dv by dt. This is what is force, rate of change in momentum. So in this case, we already know what is the change in momentum, and rate of change is dt, nothing but every 0.1 second it is happening. So we can find out what is the rate of change of momentum, which is basically responsible for balancing this downward weight of the metal plate itself. So finding that is quite simple. Minus 2 mu, already 2 mu we already found out. So 2 mu divided by 0.1 or t. U is unknown, m is already known, t is already known, 0.1 impact time. So that is what is balancing your weight. So we'll simply say that capital mg, or nothing but 50. Okay, so we are just balancing this right now. So capital mg is equal to 2 mu by t, right? So capital mg is acting downward and 2 mu by t is this. or we can directly write, that's what I was telling. So U equal to mgt by 2m. So m is in grams, so we said 10 to the minus 3. G already we know. T let us replace, and 0.1 we already know, and then 2m. 2m is 2 into 10 into the 10 gram into 10 to the minus 3. That is how we find the velocity. So velocity with which it should be fired is 2.45 meter per second we get. So this is the next problem, which says that three identical blocks, each of masses m, along the frictional stable is being acted upon with a force F. This is the force F, and we need to find the force exerted by X on Y. So these are three different blocks. M, M, and M is the mass of each of this block. So we need to find the force exerted by X on Y and the force exerted by Y on it. So we are given that the force exerted on all these blocks together is F, capital F. So we need to find this force, and we need to find this force, right? So what is given is the applied force F already, right? And the total mass we already know, m plus m plus m is 3m. So let it generate an acceleration a. Let us assume that it moves forward, this all the three blocks together, all of them together with an acceleration a. Because they are combined blocks, so they will move together with an acceleration a. So what does it mean? So 3m into a is F, right? So we get F equal to 3ma, the total force equated with mass into acceleration. So total mass into acceleration. Now for this block, let the force be F1. So the X exerts on Y, to X to Y, let the force be F1. And this block also we know is moving with an acceleration A. This block also is moving with an acceleration A. So which means that 2m into A is the force exerted. So what does it mean? F1 is equal to, so this is moving with an acceleration already we know. So the resultant force responsible for this is F1 is equal to 2ma. So we already found what is F1, but in terms of F we need to know, right? Because we don't know, we have a known force already F. So in terms of F, what it is nothing but 2 by 3 F, right? 2ma is equal to 2 by 3 F, or we can also say from here A equal to F by 3m, right? So this means that 2ma is equal to 2m into F by 3m, okay? So which is nothing but 2 by 3f. So this is the answer for F1. Now let the other force that is being acted from X to Y to Z, right? So let it be F2. So this F2 we have, and this part, because of this F2, what is happening is this particular part is moving. The jet block is moving with an acceleration A, because all of them will have same acceleration, right? So what does it mean? The overall force F2 is nothing but ma, right? So which means that it is, capital F is 3ma, so ma is nothing but F by 3. So X to Z we get 2 by 3 F, and from X to Y we get 2 by 3 F, and from Y to Z we get F by 3. So this brings us to the end of this particular topic, and the upcoming topic will be the topic 15 on class 9, where we are going to discuss about gravitation, universal law of gravity, and law of planetary motion. So till then, stay tuned and keep sharing the videos to keep me motivated. Thank you. Thanks for your support.